All right, guys, so this is our 5.4 homework help video. I had some students requesting help on the following problems. I'm going to be doing numbers 25, 27, 29, 31, 35, and 37. Okay? So let's go ahead and get down to business here. Number 25. We have x minus 1 squared times x plus 3. And that's our function, which we're going to call f of x. The directions are asking us to find critical values and intervals of increase and decrease. Now, since this is a problem that I assigned yesterday, let's just focus on finding the relative minima and maximum and ignore the directions here. You could still do all those things that it says in the directions, but all I really care about is that for this one is that you guys found the where the relative extrema were. So when I gave you guys a hint on this one, the hint that I gave you was to multiply this out. In my opinion, it would make life a little bit easier. So if you multiply this out, that's going to give you x squared minus 2x plus 1. And then we have to multiply this one out as well. Okay, so now I'm not going to spend too much time with this basic algebra stuff. I'm going to assume that if you guys took the time you could figure these out, but that's going to be x cubed, negative 2x squared, and 3x squared is going to be x squared, x, and negative 6 is going to be negative 5x, and then 3. So I went ahead and multiplied it all out. I FOILed them out, and there's my function. So now that I've got that, you guys can see that this is going to be pretty straightforward at this point. So you're going to find your derivative, right? And then from there, we're going to find where it's undefined and 0. Now, it's never going to be undefined, so I just need to find out where it equals 0. I hope it's factorable. It may not be. If not, we have to use our quadratic formula. There's another way we can do it on our calculator, but let's see if it factors first. Yay, it factors. Cool. All right, so we have x equals 1, and we have x equals negative 5/3. Right? Set up your line. Negative 5/3, 1, and then we have negative infinity and positive infinity. There's our intervals. All right, negative 5/3. So what is that? It's about negative 1 2/3. So I would say a good test point for this region would be negative 2. Good test point for this region would be 0. Good test point for this region over here would be 2. All right. So you could do this however you want. You could do it by hand, calculator. The way I like to do this is whenever I have a factored form, I like to just use that if I can. If I plug in negative 2 here, you're going to get a negative. And negative 2 is going to give you negative. 2 negatives make a positive. So this is going to be positive. If you plug in 0, go back to the original, everything cancels out except the negative 5. So that's going to be a negative. And if you plug in a positive 2, you're going to get a positive here and a positive here, which is a positive. So our slope goes up, down, and up. So f of negative 5/3 is a max, and f of 1 is a min. And you go ahead and plug those into the original function, which you could use this one that we expanded out, or you can use the original one that they gave you in the textbook. If you don't mind, I'm going to go and skip that for the sake of time. I know you guys can figure that out by hand or on a calculator, but that's pretty much the gist of it there. All right, moving along. Let's go ahead and take a look at number 27. Number 27. I gave you a hint for that one as well. My hint on this one was that you guys should write it out as two separate fractions, and what I meant by that was this. So this simplifies, right? And you can actually rewrite this like that. Much easier if you rewrite it like that. At this point, I think I'll go ahead and find the derivative for you guys. But at that point, I think that you guys should be able to handle it. Ah, heck, I'll go a little further for you. We can factor this, right? It's a difference of squares, isn't it? So that's going to be x squared plus 1, x squared minus 1. Now this one's done, but this one is actually yet another difference of squares, right? Now if you set this one equal to 0, you get -1. If you set this one equal to 0, you get 1. If you set this one equal to 0, it's undefined. This one does not give you any critical values. If you set equals 0, you're going to end up with a square root of a -1, which doesn't make sense. So you only have now this is not this is not a place where the derivative is undefined, so maybe I should be a little bit more clear. I'll just put does not produce a critical value, because if you try to solve for x, you can't get an answer out of that, so there's no critical value for that point, for that particular factor. All right, so I'll leave that one there and let you guys take on the rest. Let's move on to number 29. For number 29, okay, that's where we start getting into the weird math stuff, fraction exponents, right? So let's see, what's up with that? So derivative first, right? Oh wait, no plus 1. Plus 1's gone because the derivative of 1 is 0, right? So we have this. Now you need to rewrite this so that it makes a little bit more sense. Now, we talked about fractions. We talked about how if you want to find out where the fraction equals 0, you set the top equal to 0, but you can't. So there's nowhere where this derivative equals 0. It does not give us any solutions. However, if you want to find out where the derivative is undefined, you set the bottom equal to 0. Now that's pretty easy to solve. The only thing that's going to possibly make this 0 is if x equals 0. So you end up with one critical value there. Okay? So that's pretty straightforward. At that point, I'll let you guys take over and finish it. All right. After that, we have number 31. 31, x plus 2 to the 2/3 power. What are we calling that? F of x. Okay, so f prime, this is going to be a chain rule, right? So we're going to move this power to the front. It's going to be 2/3. We're going to take 1 away from that. And then we do the derivative of the inside, but that's actually pretty pointless because the derivative of the inside is just 1. And when you multiply that by 1, nothing changes. So we can kind of skip the derivative of the inside here. But I do want to rewrite this. Once again, the negative exponent is going to get moved to the bottom like so. Once again, you're going to want to find out where the numerator equals 0 and where the denominator equals 0. If you find out where the numerator equals 0, that tells you where the function itself equals 0. If you want to find out where the function is undefined, you set the denominator equal to 0. So now you can't set the numerator equal to 0, so once again, there are no critical values where the function is, the derivative is equal to 0. However, we can set the denominator equal to 0 to find out where the function is undefined. So if I divide both sides by 3, I get 0. I want to get rid of this 1/3 power, so I'm going to raise both sides to the 3rd power to cancel out that 1/3, right? So that's going to give me that. And so we actually end up with a pretty nice little critical value there of -2. And that's our only critical value. And once again, from there, I'll let you guys take it home. Okay? Let's move along to number 35. (2x plus 1 over x). Okay. So for starters, I need to take the derivative, right? This is not derivative friendly. You could do low d high minus high d low. It's a lot of extra work. Personally, I just want to give it a negative exponent and do the power rule. So move the power to the front, take 1 off the power. Let's rewrite that in a little bit more of a clean fashion. There we go. There's our derivative. Now, at this point, I suppose we could probably just start by setting it equal to 0. Let's see how that goes, right? You might want to, I mean, the alternative way is to get a common denominator here. However, I think we can kind of just go at it from setting it equal to 0. I think we can also find right away where it's undefined as well. It's undefined, obviously, at 0, right? You can't have 0 down here, so that's one of our critical values. The other one would be where the function is equal to 0. So if we have that, what I would do first is I would add this 1 over x squared to both sides. Okay, and then I would multiply both sides by the x squared, divide both sides by 2, and then square root both sides. Now when you take the square root, don't forget your plus and your minus. Once again, the answer in the back of your book, they're going to be writing it like this. You know, if you simplify this, you get 1 over the square root of 2, and then if you multiply the top and bottom by the square root of 2 to rationalize it, you get this. However, it doesn't matter to me how you write it. If maybe you just did it on a calculator and got this, it really doesn't matter. Either way works. So we have 3 critical values. I have these ones. I also have this one here. Okay. So at that point, I think you guys could probably find your critical values on your own. I'm feeling like maybe I should do this one. I don't know. Let's see what happens. So we have negative 7.707, 0.707, infinity, negative infinity. All right, so here I'm going to try the derivative. So the derivative to the left here, let's say, is -1. In the middle here, u, negative 0.5, positive 0.5, and 1. All right. So let's see how that pans out. Now, this derivative is pretty easy just to check mentally. I think, maybe not. For some of you it may be, for some of you it may not be. Like if I do -1, that's really easy, right? If you plug in -1, it's going to be 1 squared over, and 1 over that's